Hey, what's up? This is Madan here, and I have another video from a very important chapter that you all of are required to go through, and that chapter is haloalkanes and haloarine. And in case you remember, I have done a couple of topic earlier. I just let you know what topic I have done earlier. There was one classification of haloalkanes and haloarines. There was nomenclature of haloalkanes and haloarines, and then there was preparation of haloalkanes and haloarines. The fourth video was for physical properties of haloalkanes and haloarines, and then there was fifth video that was for some name reaction like Sandmeyer reaction, Finkelstein and Schwarz reaction. The sixth video I made was about chemical properties of haloalkanes and haloarines, and I covered SN2 reaction. So this is going to be the seventh video from haloalkanes and haloarines, where I will be talking about SN1 reaction, right? So I'll be talking everything about SN1 reaction. I hope this is going to be really worthy, and you're going to get it a lot more than what you ever had about the SN1 reaction, right? So let's start with that. So what we have to start is called SN1 reaction. So this is what the topic is: SN1 reaction. So what this SN1 reaction is, in case you need to know what happens when a haloalkane is attacked by a nucleophile. When a haloalkane is attacked by a nucleophile, the halogen is replaced by the attacking nucleophile. So this is what happens. It forms R nucleophile, and the halogen itself gets separated. So this is called nucleophilic substitution reaction by the haloalkane. Now there are two types here. I've already mentioned there is one called SN2, another is called SN1. So I'm not taking you through the same topic again, because I've done SN2 very well in the previous video. You can check out going to the channel link, and but you have to search it a little bit. So right now I'm taking you through SN1 reaction. But let me introduce what this reaction is. When substitution nucleophilic reaction takes place in polar protic solvent, it follows SN1 mechanism. It follows SN1 mechanism. So what their SN1 is? S, you do know S represent to substitution. S represent to substitution here. The N represent to nucleophile or nucleophilic, while the 1 represent to first order reaction. Now there is something I have to inform you. Why this is a first order reaction? It is first order reaction because the overall reaction depends on concentration of alkyl halide and not on the nucleophile. So this is very, very important for you. I tell you what, this whole reaction is called SN1 reaction because the entire reaction is in first order reaction. Why? Because everything that goes with the reaction depends on the concentration of alkyl halide or not on the concentration of nucleophile. So that is why it is a first order reaction. I hope you understand. This is a nucleophile here. The nucleophile is OH, right? and it reacts with tert butyl bromide. This is a tert butyl bromide. So this is your haloalkane. In case you have problem, what is this? Haloalkane, and there is your nucleophile. Nucleophile. So what happened during the reaction? You have to use a polar protic solvent. You have to use a polar protic solvent. And what a polar protic solvent is? A solvent that produces hydrogen ion is called a polar protic solvent. So I'm letting you know so that you don't have problem at all. Polar protic solvent. Right? Now what happened? The product coming out to be, the product is tert butyl alcohol. Tert butyl alcohol. But there is another product which is also a tert butyl alcohol. Which is also tert butyl alcohol. However, this one is called retention. This one is called retention, but this one is called inversion. This one is called inversion. Why there are two products? I'm coming to that, but let me repeat back the whole thing here. When a nucleophile like OH attack tert butyl bromide, a haloalkane, in presence of polar protic solvent, the bromine is substituted by the hydroxide ion and it produces, tert butyl alcohol. These are the two products. Right now you can be even happier with the one of the product, but I will tell you on the later on why there are two products in the reaction. Right? So let's go and get through the mechanism of the reaction. So I'm doing the mechanism right now. So mechanism of the SN1 mechanism of SN1 reaction. This is what the whole thing I'm about to do. You know what? This reaction takes place in two steps. The first step is called formation of carbocation, and other is called addition of, or simply substitution by the nucleophile. The first step is breaking of the bond between carbon and bromine. So when the bond is broken, now it forms a carbocation. Right? This carbocation and the bromide ion is released away. So this has a trigonal planar structure. So in the very first step, what happened? The bond between carbon and bromine breaks to form a carbocation. This is a tertiary carbocation here. Now there is very important question, where does this energy come from? To break the bond between carbon and bromine, where does the energy come from? And there is the answer. When the attacking nucleophile, undergo interaction with water, with the polar protic solvent, some amount of energy is released, and that energy actually initiates the breaking of the bond between carbon and bromine. Let me repeat back the whole thing. I was talking, where is the energy coming from which is required in order to break the bond between carbon and bromine? The answer is, when the nucleophile undergo interaction with the polar protic solvent, a certain amount of energy is released, and that energy is utilized to break the bond between carbon and bromine. So this is the first step where the carbocation is formed. But what I'm doing right now, I'm going to write that. So due to interaction between nucleophile and polar protic solvent, energy is released, and that energy that energy is used in breaking the bond between carbon and bromine. So this is very, very important, information you have to understand, that in order to start the reaction, what happened? The nucleophile interaction with the polar protic solvent, which result releasing a small amount of energy, and that energy causes breaking of the bond between carbon bromine, and hence it forms a trigonal planar tertiary carbocation, and bromine ion is separated. So this is the first step. What this first step is called? Formation of carbocation. Right? Let's go with the second step now. This was your first step. Now what I'm talking is the second step now. This carbocation here, is symmetrical. You need to understand that this is symmetrical and have a hybridization of sp2. It has hybridization of sp2 and it's trigonal planar. Trigonal planar. So what that means? The attacking nucleophile can attack in this direction, but that nucleophile can also attack from this side as well. So if attack from this side takes place, this is what the product going to be formed. This is what the product going to be formed here. So OH is on the right side, and this product is called retention. This product is called retention. What retention is? What retention is? When the integrity of bond is preserved. Let me write here. When integrity of bond is preserved, the product is called retention. It's called retention product. So this is what retention product. Let's go back and talk over there. So what happened here? What happened here? The OH, when attacked from this side, it forms inverted product. It forms inverted product. This is your inversion product. Inversion product. If the attack on the carbocation takes place from the left side, the OH will attach to the left hand side, and then the product will be called inversion product, and this will be called tert-butyl alcohol. This will be also called tert-butyl alcohol, but the only difference between these two products are that OH here is on the right side, but OH there is on the left side. Why it happened? Because tertiary carbocations are symmetrical, right? And therefore the attack can take place from either of the side. So that is what the reason is. Now let me write the reasoning part here again. Because tertiary carbon, because 3-degree carbocation is trigonal planar by geometry. So nucleophilic attack can take place from either side, which result formation of 50% inversion product, and 50% retention product. 50% retention product. However, this takes place when the alkyl halide is optically active. So there is something new coming up, which I will be talking in the next video. Let me repeat back the whole thing so that you understand each and every part. But in case you need, you have to make a copy for that. So you can pause it right here and copy. Okay, so let me repeat back the whole thing. SN1 reaction takes place when the whole nucleophilic substitution reaction is carried out in presence of polar protic solvent. How the reaction starts? In the beginning, first step involves formation of a carbocation. How the formation of carbocation takes place? The bond between carbon and halogen is broken using the energy released by the interaction between nucleophile and water. And after that, the carbocation is formed. In the next step, since the carbocation can be attacked from both sides, so the nucleophile attach itself from the both side, from the left side also, but from the right side also. There you can see it's from the left side, and there it is from the right side. So the two types of product are formed. In one of the product, the nucleophile is on the right side. In the other one, the nucleophile is on the left side. So if you see, this seems to be the different side of where the initial halide ion was. So this is called inversion product, while this one is called the retention product. Now the question is, why there are two types of product and when there will be two types of product? The answer is right here. I've tried to maintain, write everything and explain you. Because the 3-degree carbocation is trigonal planar by structure, so nucleophilic attack can take place from either of the side, and therefore 50% of the product is inversion and remaining 50% product is retention, right? So let me write back here again. This is 50% and this one is also 50%. So this is something else also generating, but this only happens when the alkyl halide is optically active. So this is the new topic coming up, which I will discuss in the next video. There's something about. So I hope you have understand that the SN1 reaction is not only a substitution nucleophilic reaction, but it's also a first order reaction. I made you know that. Another thing is that out of these two steps, you have to understand the last line I'm saying is very, very important. The SN1 reaction takes place in two steps. So the first step is the slowest step. What that means? Formation of carbocation is slowest step, and if a reaction takes place in more than one step, then the reaction which is the slowest is called rate determining step here. So this also result another topic here, and that is called rate determining step. You might have studied in your chemical kinetics chapter, but let me repeat back the whole thing. If a reaction takes place in more than one step, then the reaction which is the slowest, that decides the rate of the reaction. So in this particular case, the first reaction where the formation of carbocation was taking place was the slowest, and therefore it was the rate determining step. So this is how I've tried to make you everything possible about the SN1 reaction, like what is the role of polar protic solvent, how there are two products formed, and why this is called first order, and etc, etc. I hope you have understand so much and almost everything, and do let me know about. But I have to wind this up and say one last thing I have to say, that thanks for watching and thanks for being every time I try to make a video and there is a reason you watch. So that's it.